Hi, and welcome to this applied A2 alkenes question. It's an A2 style question because of the level of problem solving that's required, even though alkenes is a first year topic. So this would easily be A or A star challenge due to the applied nature of the question. So let's have a look through it quickly. Myrcene is a naturally occurring hydrocarbon containing more than one carbon-carbon double bond. It gives us a picture of myrcene there, and also the empirical formula, or molecular formula. A reaction of 204 milligrams of myrcene with hydrogen gas produces a saturated alkane. They ask you to calculate the volume of hydrogen gas in centimeters cubed and measure it at RTP, which means that volume is going to be 24,000 N. So you need to show your working. So the number of moles of myrcene in 204 milligrams, you've got to convert milligrams to grams. So you remember to divide it by 1,000. So we have 1.5 times 10 to the minus 3 moles of myrcene. Now the problem is 1.5 times 10 to the minus 3 moles of hydrogen would only hydrogenate one carbon-carbon double bond, and myrcene has 3. So if you look carefully, you can see them on the structure. If I take the cursor, there's one at the end, one here, and one at the other end here. So therefore, 4.5 times 10 to the 3 moles of hydrogen gas is required. So when we do V equals 24,000 N, we need to multiply 24,000 by 4.5 times 10 to the minus 3, which gives us 108 centimeters cubed. The second part of the question is where it gets particularly challenging. So we've already worked out that V equals 24N. We're dealing with decimeters cubed this time, so to work out the number of moles of hydrogen needed in 5.28 decimeters cubed, that's quite straightforward. So you divide it by 24 and it gives you 0.22 moles. Now that's 0.22 moles of hydrogen required to hydrogenate 0.02 moles of beta carotene. So to work out how many carbon-carbon double bonds are present, you need to divide 0.22 by 0.0200. So that means you've got 11 carbon-carbon double bonds present in beta carotene. Each carbon-carbon double bond will reduce the number of hydrogen atoms by 2, starting from the general formula of an alkane, CnH2n plus 2. So applying CnH2n plus 2 to the fact that beta carotene contains 40 carbon atoms, you end up with C40H82. But 11 carbon-carbon double bonds present would mean a drop of 22 hydrogen atoms. So taking into account just the double bonds, you'll have C40H60. However, we're not finished yet because it says it's got 2 rings. And if you remember, alkenes are isomeric with cycloalkanes. So therefore each ring will be a further drop of 2 hydrogens. So you drop a further 4 hydrogens to get C40H56. So if you get C40H56 and add it to 11 hydrogens, or react with 11 hydrogens, you get C40H78. Okay, so hopefully this has been a useful look at how to problem solve your way through a particularly challenging question on a relatively straightforward topic. Until next time, thanks for listening and see you soon.